dear students. Today we have proposition 17 of book 3. Given a circle and a point not on that circle, or not within that circle either, to draw from that point a line touching the circle. Not cutting it, not missing it, but touching it. Amazing. Let this be our given circle, and let this be the point outside of the circle. Thus, it is required to draw from this point a line touching this circle. How are we going to do that? Well, let's start off by taking the center of this circle, and let's connect the center with a straight line from the point, the aforementioned point. Let's go. You'll see why I'm doing this later. Okay? And let's take this line as a radius, hold this fixed, as a distance, hold this fixed and swing it around and make ourselves a lovely blue circle. See how well I can do this? Feissima. But I'd rather you guys do that and do the drawing in your presentations than have it already done on a computer. Doesn't make any sense. So I try to do this a little bit better. Okay? So now we have one circle and two circles. Sorry for the ugly circle. Great. Let's see this point of contact. Let's drop a line perpendicular, given a line and a point not on that line, or a point on that line to draw a line perpendicular. So let me see, which one do I want this to be? Because that's going to be this. I'll do this one in green. Drop a line perpendicular. Okay? Now, at this connection point, at this cutting point, let's connect these two lines. Great. I'm going to do the same thing over here. Dash that line. Okay? Then I'm going to do some green stuff in here and some red stuff in here to help you in your imagination as I'm doing this problem. Okay? And let us connect. Let's drop a line from this point to this point, and that's going to be our line which touches. I just gave it away, the excitement of the problem. We got to prove that that's touching it now. I can't just say, well, it looks like it's touching it. You got to prove it. Okay? Now, let's look at these two triangles. The green triangle and the red triangle. Okay? Sharing things. Okay? We know that because this is a circle, this side is equal to this side. This and this are radii of this circle. They're also sides of a triangle. Okay? We know that in this circle, this side is equal to this side. They're radii of the same circle, the black circle, okay? So here we have two triangles with two sides equal to two sides. Remember, these two sides are equal because they're radii of this circle. These two sides are equal because they're radii of this circle. Now look at this triangle. It has this radii, this radius as one of its sides, and this radius and this circle as another one of its sides. And in this triangle, it has this side as the radius of the circle, and this side as the radius of this circle. And this are equal because they're radii of the same circle, and this are equal because they're radii of the same circle. So now we have two sides in this red circle, 1, 2, equal to two sides in this green circle, 1, 2. And look at this. They contain an equal angle because they share that angle. This angle is part of this red triangle, and this angle is part of this green triangle. And the two equal sides are about that very same angle. So here you have two triangles, side angle, side, with two sides equal to two sides, and the angle they contain are equal. Therefore, the base is equal to the base. And the remaining angles equal to the remaining angles, namely those which subtend equal sides. Now look at this. We drew this, remember we drew this at right angles, so this angle in this green triangle is right. And this angle is subtended by this side, which is equal to this side in this red triangle. Therefore, this thing must subtend an angle, this line must subtend an angle equal to this angle, which is this. Here's what it subtends in this red triangle. Here's what it subtends. Okay? Now we know that that's right because this one is right and we showed that they're equal. If this is equal to this and this is a right angle, this is also a right angle. Well, there you have it. We know from our bag of knowledge, I don't remember what prop, corollary from previous prop, that if you have a circle and you draw a line at right angles, yeah, just the previous prop, anterior to this one, prop 16. We dropped a line perpendicular. We showed that it doesn't cut it, nor does it go along the circumference. Therefore, it falls outside. And then the corollary to that was, if you continue it, that line will be touching the circle. Obviously, it can't be cutting it. We proved that it can't be cutting it. You can go look at that prop if you want to see the truth of that corollary. We talked about the corollary in the demonstration of the prop. Great. So we've drawn this line. This line is at right angles to this line. We know that if a line be at right angles to the diameter of a circle, it touches that circle. So look, remember we dropped this, we connected this point to this point. That was our original point. We connected this point, and if you continue it, it necessarily just touches the circle. How do we know that? Because this is drawn perpendicularly to this, and we proved that it was perpendicular by showing that it's equal to this using side angle side. Therefore, we have quod erat facendum, what was to be done. Given a circle and a point outside that circle, to drop a line which touches the circle. Thank you. Bye-bye.